So we should be live now. I want to greet at first everyone who is joining this webinar. It's yet another Cloud Study Network meetup, webinar, call it as you want. Today we have a really exciting topic about testing and microservices. And we have Christoph with us from Ebeling Consulting. Christoph, stage is yours. Introduce yourself, please, a little bit about yourself, about your company, what you guys are doing, where you are. And yeah, that would be amazing as a start.
Yes, of course. So first of all, thanks a lot for having me, and thanks a lot everybody for joining today's webinar. My name is Christoph, and I'm the founder and managing director of Ebeling Consulting. I have been working as an IT manager and consulting for multiple years, and last year founded my company Ebeling Consulting in order to help clients with cloud migrations, cloud microservice architecture, and testing of cloud systems. In the last years, we have been working a lot with testing or with helping in testing strategies for microservice architectures as well as other cloud solutions. And today I would like to share some of the insights that are valuable for testing microservices that we have been figuring out the last years. And yeah, just put them in a presentation for you. So here we go. I hope
that's amazing. Christoph, where are you located actually?
I'm located in Berlin. Our company is based in Berlin. We are at Potsdamer Platz, but we also have a lot of developers basically sitting everywhere around Europe.
Remote work, right?
Remote work, I think it took off pretty much after Corona. So yeah, I think it's a good thing. And the developer happiness also increased a lot for both for us and for clients. So I think it's definitely the right way to go.
Where are your clients actually located? Are there mostly around Berlin, or is this international clients, or primarily like DACH region, like German-speaking region?
Yeah, we primarily have clients in Germany. We have a lot of clients in the mobility sector. For example, VW Group, we are supporting a lot with, and other clients like ADAC, but I'm also supporting some smaller startups. But yeah, the main focus is in the DACH region.
Okay, so if you are sitting in the DACH region and watching this webinar and really interested in topics like DevOps and cloud native technologies, I think Christoph would be, and his company would be a nice place to go to. And Christoph, go ahead. Let's just jump straight into this topic. And yeah, feel free to. I see you already sharing your presentation. It's great. Let's go.
Okay, great. Yeah, thanks a lot. So today in our presentation, I would like to talk with you about testing strategies for microservices. And first of all, what we will do is we have a really quick recap with testing strategies. Don't worry, I will not annoy you with evangelism, how important testing is. I think in 2022, we all know that testing is essential for a successful company, especially if you want to run microservices, especially if you want to go in the cloud, and especially if you want to have a high time to market. However, since not everybody here might be on the same place, we have a really quick recap on testing strategies for microservices before we move on and evaluate the eligibility for cloud microservice deployments of those strategies. And afterwards, I'm going to share with you some examples how testing strategies for microservices can look like, and show you two specific strategies for testing microservices. So first of all, I would like to have a look with you on the reasons why we do automated testing in the first place. And of course, we want to know if our application is working well, but still manual testing for some of us, it can be faster. The only problem is if we do manual testing, we do not cover regression, we do not have documentation, and we do not have the insurance of code quality. And I think especially the part with the documentation is highly underrated. Because if you have tests, and especially if you do tests in a BDD style deployment writing, then you have the really big advantage that you can have those tests and they describe the functionality of your software. I often saw people who has been writing software, and years later, people were asking themselves, what is the software actually doing? How has it been working? And what was this part of the software meant for be? And then you have the scenarios where, for example, one part of the software is not working correctly, but you don't know what is the root cause because you don't know the actual specifications. So testing manually can definitely be fast in the short run, but only automated testing will ensure you that you can keep this speed in the long run. So the question now that we figured out that testing is highly beneficial for everybody is why testing is not been done in the first place. I've been going through so many companies in the last years, and they all told me, Christoph, we would like to do more automated testing, and we think automated testing is doing right, but we somehow struggle with it. It somehow didn't take off for us. And I've been writing down some of the main parts I've been seeing why automated testing didn't take off. And the first one, obviously, it's pretty obvious. People are missing the right tooling. If you want to write tests every day, then writing automated tests will be 50% of your work. And if 50% of your work is based on shit tooling, you will just not do it. So if you don't have the right tooling, automated tests, it will probably not work nice. So make sure you get the correct tooling. The second one here, it's definitely slow CI servers. If you have a slow CI server, then you will probably never get the builds that you want, and the whole testing architecture, it will be holding your developers back. So if you have a slow CI server, which means everybody who's doing something needs to wait for the CI server 10 to 15 minutes, people will not do it. And the third one is definitely lack of knowledge about the testing framework. If you have developers and you want them to write effective tests, you have to teach them how to use testing frameworks properly in order to leverage the full potential. So those three things I saw a lot, and to be honest, those points are pretty easy to fix. But there is another thing, and we have two parts that are not that easy fixable, and those are that you don't have the correct to have too much effort for low return of investment, and that you have bad software architecture. And those 2 points are actually pretty much related, and they are not that easy to solve. Because if you have the bad software architecture, then writing tests will not be efficiently. And the same thing is with the high effort. I see a lot of teams, and they start writing automated tests. And after a while, they say, Christoph, we spent so much time in writing tests, but we actually never got the return of investment that we were hoping for out of those tests. So the question here is, why is this the case? And in order to answer this question, I would like to zoom a little bit out and ask ourselves, what is the goal of all this testing? And the goal of all this testing is to achieve continuous deployment. So we want to develop, test, and deploy our application in a cycle that is always going around. I guess I'm not telling you anything new with it. You're all aiming for this goal, but probably if we honestly ask ourselves, we have all seen teams where this has not been working so far yet. So the question is, if we do continuous deployment and if we want to deploy all the time, what should we write our tests for? And the main objective when writing tests should be, can we deploy without breaking the system? And this question might seem pretty obviously because, yes, of course, this is the whole purpose of a CI. But if you zoom out and if you have a look at your actual test design, you'll figure out it's not that obvious anymore. Because a lot of people, a lot of developers, they write code, but what they do is they write code in order to check if their code is working. Unfortunately, if you have a distributed architecture with microservices and you have an application with a lot of edge cases, it's not working that easy anymore. Because you might just test that a part is working, or you might not consider some edge cases. So one of the key findings that we have here is that you have to need a mind change. You need to think about what can fail in our deployments. Think about this for a moment. If you write a test and you consider everything that can fail, so you're not just covering the happy parts, then you actually get out way more information from your tests, and you can find out way better where your system is failing and make sure that you find the root cause for your problem. This is especially important in microservice architectures because if you go for highly distributed and highly independent microservice architectures, the root cause analysis will get way, way harder. So let's have an example to figure out what we're actually talking about here. We have this source code, and in this source code, we want to find out the monthly net spendings. So in order to do this, what our code would do is it would call our audit service, say, I want to find the orders by user ID, and then sum them up. Looks pretty straightforward so far. The only problem is now that we're on a microservice architecture to write a test here, we need a mock in order to do this. So now we have a mock here. So far, so good. We write a mock. But what we don't do is if we have this functionality here, get amount, is it net or gross? You see above we have on net spendings. And now that we mock out this functionality, we will assume that this functionality will get us the net amount. But does it really do this? This function, well, this test here will never give us the answer to this functionality. And even if it does, and somebody is changing the orders get amount functionality later, we will lose this information. So how can we deal with this and how can we solve this problem? Well, the obvious answer here is we need a different test type. So if we go and we have unit tests are actually pretty fast on execution. They are good for complex systems, but they are unfortunately not sufficient at all to ensure software is working, and they have a really high effort to maintain. And I think this is what I already was referencing to in the beginning. I've been seeing a lot of teams that spend a lot of time in unit tests. And the problem here is that especially with smaller projects, with some startups, most companies don't have the high psychometric complexity mentioned in part 2. So they just spend a lot of time on adjusting unit tests, and they don't really get the insights. And there's also another problem about the unit test. The unit test is only good if you are 100% sure how your software architecture will look like. So if you have an architecture that is pretty clear and that is not changing that much, then a unit test might be good for you. But if you're a startup and that is rapidly prototyping, a unit test, it's, to be honest, completely worthless because the architecture of your whole application can change all the time. So what is the alternative? I'm pretty sure a lot of people now are thinking at home, this is pretty obvious. We need end-to-end functional tests. End-to-end functional tests test the whole application. So it pretty much enables us to deploy the software with confidence. Sounds pretty easy so far, but I could see, if we were in the same room, probably in a lot of faces that are a bit concerned right now because end-to-end tests have a really big disadvantage, and they are hard to maintain, and they become even harder to maintain the bigger your application gets. Some people maybe have experience from the old time where we were playing around with Selenium. Right now it's a little bit better, but it's actually still problematic. So end-to-end tests, they cannot be the solution for this. And I guess most of you, at least the more experienced developers, know what comes as a solution usually, and it's the integration test. The integration test is pretty straightforward. Usually you test from somewhere in the application, and then you test until you reach a database, give the result back, but you don't test the front end. So you test the integration of different service components in your application. The integration test will actually solve the mocking problem for us and will also solve the question if we have net or gross in our application, because we test all this functionality in combination. So back in the days, this talk would now have been finished, and in a 2013 Java world, this would have been the solution. I guess a lot of you are already familiar with the solution, and I'm not explaining something new for you. So unfortunately, those integration tests that can test a big part of the application and that are still fast enough on modern computers are not quite sufficient for testing microservice architectures. And I would like to have a look with you why this is the case. Requirements. So integration tests basically require, or microservice architectures require our application and services to be loosely coupled, and they should be able to deploy it independently. So if we do this, teams might work at different times. They will work with different tech stacks, and you can't expect them to almost communicate. So let's do a little mind game and see how the implementation of an integration test could look in a microservice context. Let's say we are the team that is maintaining service A, and we would like to test this service. So what we do is pretty obvious. We now write a test, maybe a black box test, in order to test service A. We're going to test the API of service A. And what service A is doing is pretty straightforward too. Service A is now calling service C and says, service C, I would like to have some data from endpoint 1. And we'll maybe also get data from service B. And so far, everything is pretty good. And we didn't face too much problems because we, as a team, we know how to run service C and service B because our application is directly depending on them. We are the consumers of service B and of service C. But right now, our product manager comes around and says, okay, service A team, I have a new requirement for you. I would like to implement a new feature. This new feature needs to get data from service C. So service team A, they say, okay, we start this whole development process, pretty good so far, and we're going to get some data from service C. So we're going to start getting data from service C, but we figure out, okay, the API that we want to use, it's not implemented yet. So what do? We actually go to the team of service A. We get a not implemented, and our merge request cannot be changed. This is a big problem. You know, if you have a feature branch and you cannot merge it in a certain time, you'll probably never merge it. So what you do is you, as a team A, go to team C and you set up an email and you write, team C, we have created the new feature, but we can't deploy it because you're missing an API endpoint. Please check out my branch, then run my new container, deploy it with my new fancy MongoDB, run the test and make it sure everything is working fine. It would be sweet if you could also test the errors for me. Please don't forget to load my fixtures, run migrations. Oh, and hey, sometimes service A test times out, just rerun it. In case of any problems, feel free to hit up our intern. So this is a pretty sad part of the presentation because I can't hear you laughing now, but you might have seen this is not really a practical solution. So now we have our integration test for microservices, but we actually figured out, okay, this part, it's just making everything worse. So I would say I want to have my mock back, but maybe we need to adjust it a little bit in order to work with the microservice context. So let's have a look together. What was our problem with the mock in the first place? We didn't like mocks in the first place because we mocked out an API that could have a different interface. For example, in the previous example, we said, okay, we want to get the net amount, but we were not sure if we were actually getting the net amount. And the same thing could apply if we get different results, or we could have mocked API changes, but we would not figure that out. So we just mock an API, and afterwards it changes. It's pretty problematic. So what can we do about this in order to find out to solve this problem? So let's say we want to communicate this mock, and service test A is calling service A. It's calling service C again. But this time, a new feature needs to get implemented. And what we do is we ask the team C to figure out test with our mock data. So we text team C, say, hey, team C, we created a new feature. I already tested it with a mock. It works like a charm, and attached to the latest Swagger files, as well as my payload and expected JSON. Please write a unit test for our API, make it green, and let me know if you're done. Sounds pretty fair so far and way more flexible. The only disadvantage is we still have email as a communication method, and we still need to exchange data manually, so there will be an asynchronous part. Also, if our process fails, we have to do the same process again, and this might be a little bit annoying. So what can we do about this? How can we solve this problem? The unit test by team A is already implemented, and we already have our mock. But what we're going to do now is we're going to introduce a new tool, and this is consumer-driven contracts, and in our case, it's Pact. I'm not sure if many of you have been hearing about this feature. Usually, if I bring it up for a lot of people, it's new. So let me quickly explain how this is working. In this case, we will have something that is called a Pact Broker. And a Pact Broker is basically just an application that is storing Swagger files. And those files, or it's not directly Swagger files, but it's basically contract files, and they are JSON files, and you have to imagine them like Swagger files. And those files basically have all information about the API, including a required payload. And so now if I test my service A, basically what I do is I implement a so-called contract test. And this contract test, for me as a developer, it feels pretty similar to writing an actual mock. So you just go and say you have this API, you have some matches, you have some properties. But once this test has been done, everything is getting pushed to a broker. And this broker is then actually triggering a CI pipeline of a new service, which is called service C. And this service C will get all the information from the actual Pact Broker and is be able to run a verifier. And the best part of it is will get completely automated. And once you have been done with those tests, you can deploy the actual service A. And everything is going in real time. And you know if everything is implemented. So this is a pretty nice solution. And this so far will solve most of our testing problems. So for now, let's do a quick recap what we have so far. And then I would quickly check with you if there are some questions. So for now, we know that we have covered most of the big business services of our single services because we have the unit test. And we also know that the services are compatible. Hopefully, we have covered all the edge cases. At least we have covered all the edge cases that the developers could think about. So this looks pretty nice. And this is basically what we understood was consumer-driven contracts. Are there any questions so far? I'm not sure how I can
no
can
worries.
read the questions
no
here.
worries, Christoph. I'm just checking the chat right now.
Yeah.
There's one question. How does the info from Pact Broker look like?
Yes. So the information from the Pact Broker basically. The information from the Pact Broker.
Let me just quickly guess. Is it like just simple JSON data, mocked JSON data? That is what you would usually expect from API.
Pretty much. So so what you will have there is basically just it's just a JSON file, and it's basically containing API requests, and it's containing matches. So you have some matches there. So you say, for example, here it's a string expected, or somewhere there is an array expected, and then you have some sample data and some matches how you can figure that out. And with that you will then have all your data. Okay, now I managed to recover my presentation. So yeah, this is basically how the file looks like. So it's just basically just an instruction that has a schema and the payload inside. Does this answer you the question? Or
yeah, I think it makes total sense.
Makes total sense.
Yeah.
Okay.
A couple of words, because you mentioned this Pact and everything. Everyone seemed to be excited about this tool. I haven't heard about it. What can you like elaborate a little bit on it? Like tell us, is it open source? Who is a producer of this tool? How long is it on the market?
Of course.
And why you like it so much?
Yes, of course. So basically, consumer-driven contracts was a thing that has actually been invented quite a while ago. I think they started 2015, and Pact is a Ruby on Rails open source project that is also that also provides a SaaS solution. And yeah, the thing I think was Pact. The biggest advantage is that you fully have decentralized applications and decentralized tests, and so that makes it pretty valuable. However, I have the feeling it never really took off that much, at least in the not so high tech companies, because we all tend to have pretty microservice architecture that are, if we are really fair, still distributed monoliths. So the point where Pact really makes sense is actually when you go to the point where you highly decouple your applications. You can also use Pact for events. So you can, for example, use it with Kafka events instead of API calls. And I think if you have a lot of small services, then you can really benefit from this whole thing.
Yeah, that's really interesting. I think after this webinar, everyone will go and check out this tool.
Yeah,
that's something new. We all learned at least, about the tool. But
definitely. Yeah. I mean, it requires some effort, but once you really go for it, we have been implementing this for some bigger clients like VW, or we're working on it, or even the government. So it requires a lot of investment in the first place, but in the long run, it will definitely give you a lot of value because you can just finally decentralize your applications. And especially if you go for a tech stack where your whole microservices get more different, then it's even more valuable. Yeah. If you say you have a microservice architecture where you have 5 Node.js containers, all with a Postgres in behind, it's pretty easy. But once you go to a part where you say you have really specific services that run specific databases and that are not that easy to run locally, maybe some cloud-based services, then Pact is really bringing to give you a lot of value. And I think then contract testing is definitely the way to go for in the long run.
Yeah. Meanwhile, we just have another comment here from Gunnardi in the chat, and he writes, I think Spring project has Spring Cloud contract. Do you know, Christoph, about Spring?
Yes, that is also true. So there are some other competitors to Pact. So the main pattern here is it's contract testing, and once the contracts are getting generated by the consumer, then it's consumer-driven contracts. But definitely there might be some competitors to Pact. Pact definitely is the most popular tool, and it's open source tools. But yes, there is also some version of Spring, and I'm pretty sure there are some other small players on the market.
Okay, great. As of now, we don't have any further questions. I think we can continue.
Okay, great, cool. So now we have figured out how we ensure the compatibility of our services, and we assume that all our IPS are working pretty well. But there is one little thing left, and the little thing is actually not that little. So if we say we want to deploy our application now, we have to ask ourselves the question: this new architecture that we do, will it work at scale, and will it work with real user data? And even more problematic, is there anything our automated tests did not consider? For those of you who have been working in test-driven architectures for quite a while, you might know the most common mistake that you have in tests is actually wrong assumptions in fixtures, wrong assumptions in test data. And this is actually the main reason why applications that work pretty well on a local system might be a staging system, or might it be even a developer's test system, do not work in production. So you just rely on wrong data, and no matter how much time you spend on this, you will not really be able to solve this problem. What a lot of companies do is they do import and anonymize staging dumps, but this requires a lot of effort. It's pretty problematic due to GDPR, at least here in Germany, and it's just not the way to go for anymore. So there must be a better solution to actually try out your new source code in production without giving the client a bad experience and without breaking the system for him. So what can we do? There's a way that we usually can go for, and this is called Canary Deployment. And a Canary Deployment just means we show a part of the application to a really limited amount of users. You might have already seen this on tools like, for example, Facebook or Netflix. Some of your friends getting a new feature, but you have never seen this new feature. So why do they do this? One reason, of course, it's A/B testing. For marketing-wise, you want to know if a new feature is working properly. And in order to do this, you will just roll out some part of the application to a certain amount of users. But also what you want to do is you want to test your application in realistic scenarios. So what can we do? We just say we don't want to deploy Service C in version 1. We also want to deploy Service C in version 2. So now we say we want to route 90% of the traffic to Service C in the old version, but we want to route 10% of the traffic to Service C in the second version. And then we can just collect metrics from our monitoring and observability stack and see how this tool is actually performing on a production environment. So how can we do this? Those people who have been working in cloud native stacks or have been working a lot with Kubernetes probably came across a tool that is called Istio, which is a service mesh that is also open source. There are also some other service mesh solutions, and there are different ways to solve this problem. Me personally, I'm a big fan of Istio, but yeah, you can basically use every service mesh that you want here. So what is this service mesh doing? A service mesh is actually splitting traffic based on certain criteria. So for example, what we could do here is we split traffic based on certain user sharding criteria, on certain attributes. So we could say, for example, we have amount of beta testers, or just based on a time or location. And with that, we can just split traffic to an old service and to a new service. And with that functionality, we get a way more realistic testing scenario because we're actually able to try out new applications. And if something is failing, just a small part of our application fails and the rest is staying functional and the same. So sounds pretty good so far, and it's probably the way you want to go for. The only disadvantage here is still 10% of your users get an error request, which is not that good. So how can we solve this problem? And the approach to solve this problem is related to a microservice pattern that you have probably seen before. And this pattern is the event-driven microservice architecture. If you have an event-driven microservice architecture, you can basically introduce a message broker, and all services will try to do all the interaction over this message broker. This has, beside from the testing strategies, a lot of advantages for your general service architecture. For example, will it allow you to make services more independently, make them more resilient, or if events are failing, you can replay them. You have this typical scenario, for example, service A is calling service C, and then you have a timeout. So what you do, you basically have a problem. If you have a message server, a message broker, the event will get replayed and your whole application becomes more resilient. So let's say we have a message broker now. How do we test this? Pretty easy. We can just send our messages to Pact, and the process will pretty much stay the same. It's just going the other way around. So the consumer, in this case, will get the message, and he will just send the message to the broker, and then we can replay this message. So pretty nice architecture. But how does this architecture help us actually with our production deployment and with figuring those things out? So this is pretty easy, because now that we have our message broker, what we can do is we can utilize something that we call consumer groups. And with consumer groups, we actually have the possibility to give events to different services at the same time. So let's say now we have a message broker and we have a version of service C deployed in 2 versions. As you might be aware, every service has their own database, and then with patterns like event sourcing, you can store the data in both services. So right now we have the possibility to, for example, if we have a service that is doing some documentation for an accounting, or some service that is not having directly side effects on the user, to run both services in parallel and monitor how they behave. And this is a really, really great feature for testing a lot of metrics and insights you cannot test with an automated test. For example, with this feature, you can figure out, is a performance optimization working? Has resilience been increased of my service? How can I update a service? And you can even keep services running over a really long time overlap, let's say 3-4 weeks, and really see what is the long-term impact of the change I made. And do I want to keep this change? And sometimes if we, for example, talk about reporting services, you even will figure out, okay, I want to keep both of them. So this is a technique that is pretty common in companies, especially if you have a lot of data, especially if you have a lot of resources, and especially if you have a lot of data. Because the bigger your application becomes, the harder it will get to get an overview. And the harder it will get to understand how your events are actually connected to each other. Imagine, for example, companies like Netflix or Facebook who have over 1,000 microservices. It's really hard to think about the impact of changing a service before you do this. But if you have the possibility to do a Canary deployment and can just monitor what will happen and how it will change, then it's becoming way easier to do the whole thing and way easier to get insights, especially on data like performance, cost efficiency, and resilience. So this pattern is called Canary Deployments, and you can actually apply Canary Deployments for a lot of things. It's not just limited to software. Let's, for example, talk about ops. If you run a Kubernetes cluster and you say you want to change, want to test a new version of an operating system, of a database, of some service, you can do a lot of Canary deployments. And Canary deployments is actually a tool that is used a lot in the infrastructure. It's used a lot for tools that relate to performance or valid metrics. And so Canary deployments is really one of the techniques that I can advise you, especially for bigger projects, to figure out how small changes, especially to performance-sensitive data, can impact your data and can impact all the application. Yeah, so those are basically my insights I wanted to share with you on how to improve microservice architectures and how to test microservice architectures for the cloud. So just as a recap, always try to avoid end-to-end testing in the cloud. Always try to use as much contract testing as possible in order to ensure compatibility of the services, and try to get Canary releases and deployments out as early as possible to ensure that you can test your application with real data and get real metrics, not just on the theoretical functionality, but also on how they will perform with all the edge cases of your users and how they will perform performance-wise. That's everything for me so far. Thanks a lot for your attention. And now I'm really looking forward to your questions and to your discussions about testing for microservices.
Yeah, amazing. Thanks, Christoph, a lot. So everyone who is watching it right now, if you have any questions whatsoever, so what we learned today, especially that Christoph is actively using two specific tools. One is Pact, another one is Istio. Istio is like a service mesh. Its application here is really smart, and that's like at least two tools we learned about in this presentation. What seem to be like really being frequently used by you. Is there any other specific tools like you use daily on a day-by-day practice in your work, Christoph?
Well, I mean, if we talk about testing and observability, there is actually definitely the ELK stack. So if we want to talk about metrics, it's Elasticsearch, it's Kibana. We have for some clients we use New Relic as application performance monitoring. Also, Sentry can be really insightful because Sentry has some quite really cool features for release tracking. So you can actually, if you go for the Canary releases I mentioned before, see if I do this Canary release, I have new errors that started increasing. It's also open source, by the way. And then you can really track what impacts my Canary deployments will have. Beside of that, if you want to use Istio, there's a lot of tech stack around Istio with the ecosystem for deploying, for testing how everything is working there with the traffic routing. Talking about Kafka, I think this is a tool that I use as my go-to message broker. And yeah, if you have what else do I use for this? Yeah, I think those are the main tools we use for observability and for this type of testing. Yeah. Maybe in the last tool that is worth mentioning here is Argo CD. I think Argo CD is pretty good for release management. And if you want to go for microservices and want to do a fully declarative approach, then Argo CD can really help you deploying all your different service versions and keep track of them.
What's beautiful about all these tools is most of them are actually open source. So they are usually lively projects which are being constantly developed further. So they are almost never outdated. Another thing is that all of them are platform independent. Doesn't matter what kind of cloud provider or what kind of cloud providers in plural you are using. It's neutral. You can use these tools with any cloud provider. It's not a native solution. It's a third-party solution always. What makes it super flexible is also whatever customers you approach. Sometimes there are customers who are using AWS and they're not going to switch anywhere else. And this is their primary provider by contract, and you have to deal with this. You cannot just I don't know, like force a customer to a different platform to your favorite platform. It's a customer platform mostly.
Exactly. And what is even better about this is the fact that we have the possibility to deploy most of the tools via Helm charts. So all of the Helm charts of them has been really, really good, and you can just port them from one cloud to the other. I'm using especially all the tools like Istio. It's made for Kubernetes, but also, for example, Sentry. It has a really good Helm chart. We're using it for a large enterprise client as a managed service, and it's working really, really well. There are tools, for example, Istio. Yeah, Istio I already mentioned. It's really, really good. So yes, I think Cloud Native Foundation did with a whole stack, especially if it comes down to observability, a really, really great job. And I think this is definitely the way to go for if it comes down to cloud computing. And I also think this is a really, really big chance for the European market to catch up with the cloud computing industry again. Yeah, I think there are a lot of promising projects if it comes down to OpenStack cloud native deployments, and this is definitely the way that everything will go, and the way that we want to push, just to have things like data protection and security and get data back to Europe, because I think this is definitely something we want to push for, and that everybody here should push for. Go for open source, try to get stuff away from the vendor lock-in, because we made all these mistakes back in the days. If you think about Oracle, and everybody was jumping for Oracle, and then in the early 2000s we thought, okay, we finally overcame it, now we go for new stuff like Postgres, and now people are making the same mistake again and going for a DynamoDB or some vendor lock-in in AWS. So there are some advantages. We use it for some clients, but always be careful and always see, is there an open source alternative? And if there's an open source alternative, I would highly encourage everybody to go for it. Yes.
Yeah, absolutely. I guess most of the tools nowadays we are using in our daily work are open source anyways. And as you mentioned, the Cloud Native Computing Foundations mostly owns, or most of them at least, I would say. I don't want to guess like how many projects they have going on and how many have been graduated already. Probably it goes above 100 or even more. I don't know.
Oh no, it's actually above 1,000 meanwhile.
Oh my God.
Yeah,
Okay.
yeah. It's going rapidly, and it's I mean, you also have to be careful for it, because I think cloud native and Kubernetes can be a rabbit hole. And I also saw, we have to be fair about that, some clients, and they have been migrating to Kubernetes, and after half a year they spend 80% on the time on maintaining Kubernetes and 20% of the time on writing the actual application. So there's always a good trade-off, and if you want to go for this, it's the same with all the tools. Already think, are you working for the tool, or are you actually working for your own product? And if you work more for your own tool than for your own product, then I think it's a sign that you probably should switch.
And that's why customers need people like you to find the right balance, not to keep maintaining Kubernetes like as their main job. I think no one wants it, but for big enterprises, I guess it's worth it to have a team for Kubernetes, because like they serve so much like of internal infrastructure. Meanwhile, Christoph, we have another question from Michael here in the chat. The question is, how much effort and time does it require to implement contract testing?
That's a really good question, and it's really hard to answer this on a general base, but I can try to give some examples. For example, I've been implementing contract testing for some smaller projects. One of it was here a venture at Axel Springer Digital, where I've been consulting 2 years ago for price comparison. And that was pretty simple because they had some microservices that were already pretty well structured. Some of them were using events, and they also had services that were already doing mocks. So basically what we did is we just started to replace the mocks with the actual contracts. And once we have done this, it was pretty easy to go. But the problem that we're facing when we introduce contract testing most of the time is actually something else. And this is that the architecture of the application is not fully microservice-like. So if you, for example, have patterns like a shared database, or if you don't have clear APIs, if your services are not completely, the state responsibility is not clear, then it can take pretty long. So at most of the clients we see, we actually go in and we figure out that the reason why they're not succeeding with technique or with testing techniques is that they're missing the correct software architecture. And, you know, if you want to fix soft problems in the software architecture, then it usually takes a while and it requires a lot of effort. So then it can take a while, which is a reason why you should actually think about this before you do a microservice migration. If you want to go for microservices, the only advice I can give everybody is take a lot of time, really think about the service responsibilities. And once you have done that, then testing will actually work pretty easy. And this is also for me always the other way around, a good indicator. If it's hard to test your application, then your architecture is probably not good. If you have a good architecture, then it's becoming more easy to test your application.
Yeah, thanks, Christoph. Meanwhile, we have another question here from Arte, and the question is, what prerequisites are required for Canary deployment?
Yeah,
and maybe before you go into this, because we have also some community members who are absolutely like newbies, and they might not be familiar with the concept of Canary deployment. If you remember this methodology behind it, how it came into life, this term, when I guess it has been used like some years and years ago by people who are working in mines to bring with them a canary. And it was like, if can you continue, like, do you know the story?
Exactly. And then when there was some toxics, then the canary was it flying out? I think it was, yeah. And then that was the indicator that it's not going well. So basically it's the same principle here. You just deploy a little small piece to a really small part of your application where it cannot do that much harm. And once you've done that, this will give you insights on how good and how resilient your whole application is working. So it's just the idea behind it is just that you'll never know if an application is working before you have actually been trying it out. So just go and try out your application, and then you will know how it's working. And Canary deployments are just a way how to achieve this. And going back to the question from Arte, basically, if you want to implement this, it's also a question on how mature your application is, and especially how loosely the coupling is. As I showed in my second example, if you use already messages, if you have a message-based architecture, then it's actually pretty simple. But if you have a REST-based architecture, then it can actually take a while because you need to know, you need to implement Istio, you need to make sure that the service will not cause any harm. So you can do some traffic splitting, some A/B testing, but especially if it covers a core part of your business logic, you have to be careful. Also, one thing that you have to take in consideration when you do Canary deployments is that you might have different data versions. So if you have those different versions of the data, then basically what you need to do is you have to think about, okay, how can I probably perhaps migrate back and all this stuff. So it depends a lot on the maturity of your application, but I would say in general, it's an advanced microservice strategy. And once you don't have small, loosely coupled microservices, it's actually pretty hard to do Canary deployments.
So is it safe to say, like, as one of the requirements would be for Canary deployment to make it possible at all, is to have a message broker in your game, right? Somewhere in
Yes,
your
I would.
architecture.
I mean, as I said, there are some parts where you can split traffic on REST APIs just with Istio, where you don't need the message broker essentially. But in order to do it on a daily basis and to do it safe, I would say that. But also I have to say, if you're going to go for microservice architecture, you should have a message broker in general, because if you don't have a message broker and you have a service that is failing, actually there's no real way to resolve this issue. Let's say you have service A and service A is calling service C, and we say because of a microservice architecture, because of CAPM, not all services can be available all the time. You need to have a possibility to replay it. You need to have circuit breakers. You need a lot of stuff. So there are use cases where you build up microservice architectures without events, but I would say if you really try to do properly separated microservice architectures, the event where you can run without a message broker is quite rare.
Yeah, makes sense. Great. Let me just quickly check if we have any further questions. No, the chat is, I think they're amazed, the guys and girls, about the content that they have received. And that's it from the questions side. Anything else, Christoph, you wanted to share with the community?
I think that is all from my side. I would like to thank everybody a lot for listening to this webinar. I know it's almost 6 p.m. right now on a Thursday. We probably all had a hard working week. So yeah, I really appreciate your interest. Also, if you would like to chat about testing strategies, if you maybe have individual questions, please don't hesitate to contact me. You can just write me on christoph@ebeling.consulting. You will find the internet address of us also in the chat, and we always offer a free first advice if it comes down to testing for microservices or any other DevOps questions. So just hit me up and we can have a look at your architecture or just chat about testing strategies. Maybe you have some cool tools that we are not aware about, and I would be really curious to hear your opinions. Also, if you have feedback to the talk, please don't hesitate to text me. Just send me over your feedback via email or on LinkedIn, connect anywhere. And I'm really, really excited to hear more from you, from your project, and get your thoughts about testing of microservice architectures.
Thanks, Christoph, and thanks everyone from your company who made an effort to organize this event with us. Michael, also great thanks to you for the work on the background, and we will stay in touch, and that's pretty much it, right?
Yeah, thanks a lot for everybody who's listening, and thanks a lot, Karen, for having me. And yeah, hopefully see you soon.
Yeah, absolutely. It was a pleasure. Bye-bye, everyone.
Bye-bye.